Welcome to the next video of the third section, Playing the Drum Machine. In the previous video, we have learned how to load drum samples. In this video, we'll learn how to play the drum machine. Now that we have a mechanism to load drum samples and a mechanism to define beat patterns in place, let us add the ability to play these beat patterns. In many ways, this is the core of our program. Let us first understand the functionality that we want to achieve here. Once the user has loaded one or more drum samples and has defined a beat pattern using the toggle buttons, we need to scan each column of the pattern to see if it finds a green button, a true value in our data structure. If the value is true for a given location in the matrix, our code should play the corresponding drum sample before moving ahead. If two or more drum samples are selected in the same column, all the samples should play almost simultaneously. Moreover, there should be a fixed time gap between the playing of each successive column, which will define the tempo of the music. To achieve this functionality, we need to import the Pygame module to play the sounds and the time module to define the temporal gap between them. Initializing Pygame. Pygame is a set of highly portable modules that runs on most operating systems. We will use Pygame's mixer module to play the sound files. Assuming that you have installed the package, let's begin by importing Pygame. According to the official API documentation of the mixer module at this site, we need to initialize Pygame before we can play back the audio files. We initialize Pygame in a new method called init_Pygame. The mixer.pre_init method is a special requirement for our drum machine because the lack of it causes a lot of sound lagging. We will not get into the details of audio programming here, but suffice to say that the arguments to the pre_init method are. After Pygame is initialized like this, the documentation suggests the following code to play the sound. Let's add this to our code as well. Playing complete patterns. Now our program has the ability to play any sound, but we don't just need to play a single sound, we need to play a pattern. Let's define a method called play_pattern that reads our internal data structure and plays files accordingly. We can also add an associated method that returns the ith column from a matrix. The description of the code is: we create a class attribute called self.keep_playing to decide if the pattern is to be played just once or continuously in a loop. We create another class attribute called self.now_playing to track if a beat is currently playing. This will help us to make some decisions on how to handle a sudden close of program or change of pattern by the user. We then fetch the two-dimensional Boolean list from our data structure and scan each column of the list to look for true values. We get the column data from the matrix by defining a separate method called get_column_from_matrix, self, matrix, I. For every column, if a true value is encountered, we fetch the corresponding drum file path and call the self.play_sound method to play the file. The code sleeps for a fixed duration of time before reading the second column. This sleep duration defines the tempo of the drum beat. If the code does not sleep for some time between each column, all the patterns would play almost immediately and would not even sound like a rhythm. We accordingly need to import the time module to use the time.sleep method. The amount of time the code sleeps between scanning each column is decided by another method called self.time_to_play_each_column, which we define next. Determining the tempo of a rhythm. The mathematics of defining the tempo of a rhythm is simple. We get the value associated with the beats_per_minute, Spinbox widget, and divide it by 60 to get the beats per second. Then, the time to play each beat or group of beats simultaneously for a given column is the reciprocal of beats_per_second. The code is: while we are handling the tempo for the pattern, let's also complete coding the command callback attached to our beats per minute Spinbox widget. Now, let's code the functionality related to the loop checkbox. We've already factored in the looping issue in our play_pattern method using the self.loop variable. We simply need to set the value of the self.loop attribute by reading the value of the Spinbox widget. With that out of the way, let's code the command callback attached to our play button and the stop button. Our drum machine is now operational. You can load drum samples, define beat patterns, and when you click on the play button, the drum machine plays that beat pattern. However, there is a small problem. The play_sound method blocks the main loop of our tkinter program. It does not relinquish control back to the main loop until it is done playing the sound sample. Since our self.loop variable is set to true, this means that Pygame never returns back control to tkinter's main loop, and our program is stuck. This means that if you now want to click on the stop button or change some other widget, or even close the window, you'll have to wait for the play loop to complete, which never happens in our case. This is clearly a glitch. We need some method to confer back the control to the tkinter main loop while the play is still in progress. That brings us to the next iteration, where we discuss and implement multi-threading in our application. In the next video, we'll learn about tkinter and threading.